With what we learned in the prior module, a user can now navigate to any defined route in our application. But that only covered the very basic routing scenarios. What if we need to pass parameters to a route, or activate a route with code instead of with a clickable element? Or what if we need to protect a route and only allow access to it in special cases or by certain users? Or ask a user to save changes before leaving a route? In the second module on routing, we examine how to pass parameters to a route, how to activate a route with code, and how to protect our routes with guards. When we're finished with this module, we'll know how to handle additional routing scenarios, including routing to a component that requires parameters, such as our product detail component. Let's get started. We sometimes need to pass parameters to a route. For example, to navigate to the product detail view, we need to define which product's details to display. The first step to passing parameters to a route is to configure the route with parameters. We've already done this step to route to our product detail component. Here we define a slash, a colon, and a placeholder for the parameter. If multiple parameters are needed, we'd repeat this with another slash, colon, and placeholder. With the route definition in place, we can decide where we want the user to activate this route. Will we add a menu option or a data link? It is there we set the router link and pass in the required parameter. In the product list component template, we display a table of products. Each table row contains the product name, so we add a router link to this anchor tag and assign it to the link parameters array. The first element of the array is the string path of the route. The second element of the array is the value for the route parameter. When the router composes the URL, it uses this array element to construct the defined parameter. Since we have a route parameter here, we can't use the short form router link syntax we used in the last module. We instead need to include square brackets for property binding here, and assign it to an array with the routing path and parameter. To display the appropriate product, the product detail component reads this parameter from the URL. It then uses the parameter to retrieve the appropriate product and display it in the view. To get the parameter from the URL, we use the activated route service provided by the router. We want an instance of the service, so we define it as a dependency in our constructor. We've seen this syntax before. This line of code defines a private variable called route and assigns it to the instance of the activated route provided by the Angular service injector. Then we use the instance of the activated route service to get the desired parameter. There are two ways for a component to read parameters from a route, depending on how the component behaves. If the component only needs to read the route parameter one time, we use the route's snapshot to access the param map and get the parameter. The snapshot gives us route information at a single point in time. We use this technique when the route doesn't change while displaying the component. For the product detail component, the route parameter defines the product that the component displays. That parameter doesn't change while displaying the component. To change the viewed product, the user must leave the product detail page and pick another product from the product list page. If the component needs to read route parameters as they change, we use the param map observable. Recall from earlier in this course that an observable is a collection of items that occur over time. We subscribe to the observable to receive notifications every time the parameters change. If our product detail component had next and previous buttons, the route could change without leaving the product detail page. Then we'd use the observable to respond every time the route parameters changed. Check out the Angular routing course for more information on getting route parameters using an observable. In both of these cases, the string specified in the get must match the parameter name from the route configuration path. Since the product detail component only needs to read the route parameter one time, let's try out the snapshot approach. In this demo, we pass a parameter as part of the product detail route and read that parameter in the product detail component. Here in the app module, we already have the product detail component's route configured with a parameter. Looking at that route, here in the path we provide any parameters prefixed with a colon and separated by slashes. For the product detail component, we pass a product ID so the view knows which product's detail to display. Next, we need to decide where to tie this route to a user action. We can't add the product detail to the menu because we don't have an easy way for the user to specify the ID of the desired product. Let's instead modify the list of products in the product list view such that each product name is a link. Then the user can click on the product to display its details. In the product list template, we'll add an anchor tag so the product name becomes a link. We add the router link directive to the anchor tag and set up the link parameters array. In the array, we define the path of the route to activate in the first element and pass the parameter value in the second element. In this example, we want to pass the product's ID. When we view the result in the browser, we see that the product names are now links. And if we click a link, we see the ID in the URL, and we navigate to the product detail component. But that component does not yet get the parameter from the URL. Let's do that next. The product detail component needs to read the route parameter so it knows which product's detail to display. The activated route service provided by the router can help us. The activated route service provides information on the state of the current route, including the route parameters. We set activated route as a dependency by defining it as a parameter to the constructor function, and add the needed import. The activated route instance is then injected into this component class. The next question then is, where do we put the code to read the route parameter? We don't want it in the constructor. We'll add it to the ng-oninit method provided by the oninit lifecycle hook. Recall that the ng-oninit method is executed when the component is initialized. That's a good time to read the parameter and set the component properties based on that parameter. Since the parameter won't change while this component is displayed, we'll use the snapshot approach. We use the const keyword and declare an ID. Then we use the activated route instance, access the snapshot of route information, and access the param map. Then we call the param map's get method, passing in the name of the parameter to get. In our case, it's ID. Hovering over the ID variable, TypeScript defines it as a string or null. But since we're using it as a product ID, we want a number. So we'll add the number function around it. The ID is now a number. To make it easy to see the ID we read from the URL, let's display it as part of the page title. Here we use the ES2015 backticks to define a template string and display the ID. Let's see the result in the browser. Click the menu option to display the product list. Then click a product. The URL changes to include the parameter and the product detail page is displayed. If everything worked, the title displays the same parameter as shown in the URL. Yay! Before moving on, let's take a moment and talk about a common error we may run into involving undefined or null values, and how to prevent it. In this demo, we look at a common error and how to prevent it by handling null and undefined. In the product detail template, we want to display the detail for one product. So in the product detail component, let's declare a property for that product. We define its type using the product interface and add the associated import statement. We see an error. We've seen this error previously. Because we are using TypeScript's strict type checking, we need to initialize this property. Let's try initializing it to an empty object. That doesn't work. The error here is telling us that the empty object is missing the properties defined in our interface. So what do? We could use a TypeScript definite assignment assertion like we did last time we saw this error. That tells the compiler that we plan to initialize this property later. But because we will ultimately get the product data using HTTP, There will be some delay in receiving the response to assign to this property. So let's be more explicit and mark the type as iProduct or undefined. The property is then clearly undefined until the data is retrieved. Then it's of type iProduct. In the product detail template, let's add the product name to the page title. Open the terminal and we see an error. Object is possibly undefined. So now what? Here are two ways to prevent undefined property errors in our template. We could use the safe navigation operator, defined with a question mark. The safe navigation operator guards against null and undefined values when navigating an object's properties. If the product object is null or undefined, the safe navigation operator simply returns null and does not attempt to access the product name property. Hence, we won't see an undefined property error. The safe navigation operator is great, but it's not always the best option. For example, it doesn't work when used with the ng model two-way binding. It also can be quite tedious when we display many properties, like in our ultimate product detail template. There is another option. We can use ngIf and check whether the product property is defined. We add the ngIf to an HTML element that encloses all references to the product object. If the product is undefined, this element and all of its children will not appear in the DOM, so it won't attempt to retrieve properties of an undefined product. Then we don't need the safe navigation operator. We can also use a combination of these approaches. We always want to display the title, so we don't want an ngIf hiding this element. We'll use the safe navigation operator here instead. But for the product detail elements, we'll use the ngIf. We don't want to display any of the details, including any of the labels, if we don't yet have product data. Opening the browser and selecting a product, we see an empty page, but no error. The product name appears as null. Going back to the code, let's imitate an HTTP response by assigning a hard-coded product. I'll paste it in. If you are coding along, you can copy a product from the provided product.json file. Looking at the browser, we see our product name. Note that because we are hard-coding this product, we will see leaf rake regardless of which product we select in the product list page. Notice that every time we want to go back to the product list page, we select the menu option, but it would be nicer to have a back button here. Next up, let's add a back button and see how to activate a route with code. We want to add a back button to our product detail page that navigates back to the product list page. We could activate this route using the router link directive in the component template, just like we did with the menu options, but it's also possible to route with code. So let's try that out instead. When would you want to navigate with code instead of the router link directive in a template? One example is a save button, where you need to execute some code to save the data and then route. To route with code, we use the router service. This is another service provided by the router. It allows us to work with the router in code. It's different from the activated route service we used earlier in this module, which provided information on the activated route. We define a dependency on the router service using a constructor parameter. The router instance is then injected into this component class. We use this router instance to activate a route. Here we define a method that we can call from the template based on a user action. The code uses the navigate method of the router service and passes in the same link parameter array we use when binding the router link. In this example, we route to the products route and don't pass any arguments. Let's give this a try. We want the product detail component to navigate back to the product list component. Here in the product detail component, we define the router as a dependency by adding another constructor parameter. Then add the needed import. When this component class is constructed, we'll get an instance of both the activated route service and the router service. Now we can build a method that navigates with code. Since the purpose of this method is to navigate back, We'll call it onBack. It doesn't return anything, so we'll set its return type to void. In this method, we use the router instance and call the navigate method. We pass it a link parameters array. In this example, we want to navigate back to the product list component, and we don't need any parameters. We just define the route path, which is products. In the product detail template, we'll add a back button. We again use the Bootstrap style classes to give the button some style, and add a font awesome icon. We use event binding to bind the click event of the button to the onBack method we defined in the class. Now let's check it out in the browser. Click on a product. The product detail page is displayed. We click our back button, and we are back on the product list page. Let's try another one. We see the detail page. Now we're back on the product list page. Our code-based navigation is working. So routing with code involves importing the router and using its navigate method to activate the route. Now that we have several routes in place, let's look at how to protect them with guards. There may be times that we want to limit access to a route. We want routes only accessible to specific users, such as an administrator, for example, or we want the user to confirm a navigation operation, such as asking whether to save before navigating away from an edit page. For that, we use guards. The Angular router provides several guards, including canActivate to guard navigation to a route, canDeactivate to guard navigation away from the current route, resolve to prefetch data before activating a route, and canLoad to prevent asynchronous routing. In this clip, we work through how to implement the canActivate guard. You can use the same techniques we're covering here to implement any other type of route guard. We'll build a guard that prevents navigation to the product detail route unless a specific condition is true. Building a guard follows the common pattern used throughout Angular. Create a class, add a decorator, and import what we need. Here we define a guard class. A guard is a service, so we use the injectable decorator and register the service with the root Angular injector by setting provided in to root, and we import what we need. This class implements canActivate. To create one of the other kinds of guards, change this to implement one of the other guard types. We then implement the canActivate method. For simple cases, this method can return a Boolean value, true to activate the route, and false to cancel the route activation. For more complex cases, we could return an observable or a promise from this method. In the canActivate method, we write code to determine whether the user can access the route. This may involve checking the user's type to only allow an administrator to access the route, or it may involve checking the route parameters to ensure they are of an expected format before routing to the component. We built the guard to protect the product detail route, so we add the guard to the product detail route. We add canActivate and set it to an array containing the guards to execute before this route is activated. Let's give this a try. In this demo, we protect our product detail route with a guard. We want to build a guard that prevents navigation to the product detail component if the provided URL parameter is not valid. If I type 0 into the URL, I see the title display 0. But 0 is not a valid product ID. And if I type hello, we see NaN, which is short for not a number. Recall that the route definition for the product detail component includes an ID, but there is nothing here that defines this ID to be numeric or greater than 0. So our guard should prevent navigation to the product detail route if the ID is 0 or not a number. Our first step is to build our guard. We could build it manually, but why not use the Angular CLI? We open the integrated terminal and type ng for the Angular CLI, g for generate, g for guard, and the name of our guard. Since this guard is for the product detail route, we add it to the products folder. So products/product-detail. That's all that is required. Press Enter, and the Angular CLI prompts us to select the type of guard we want to generate. We can select one or more guards. For our example, we only want the CanActivate guard. Press Enter, and we see that the CLI created the guard and the start of a unit test for that guard. Let's open the resulting guard. The CLI added all of the basic boilerplate here for us. Yay! Let's talk through it. Since a guard is a service, it needs to be registered with an Angular injector. The CLI registers this guard with the root application injector using the provided-in property. It implements the CanActivate interface and builds the start of the CanActivate method. The CanActivate method has two parameters: the activated route snapshot to provide current route information, and the router state snapshot to provide router state information. The method can return an observable, a promise, or a simple Boolean value. All that's left is to write the logic for the guard. What do we want this method to do? We need to check the route URL and ensure that the ID passed in is valid. If it is not valid, we want to navigate back to the product list page. Navigation requires the router, so the first thing we need is a constructor. Then we inject in the router, letting VS Code import the appropriate package. Next, in the CanActivate, we need to read the parameter from the route. Luckily for us, CanActivate has a parameter that gives us the activated route snapshot. The activated route snapshot contains the information about a route at any particular moment in time. First, we use the const keyword to set the ID from the route parameter. Since route is an activated route snapshot, we can use its param_map property to get the parameter using the parameter name. We again use the number function to convert the string parameter to a number. Then we use a JavaScript if statement to check the parameter. If the result is not a number, or the value is less than 1, we display an alert. We don't normally want to display an alert from our application. In a real application, we'd route to an error page. That error page would notify the user of the problem and optionally provide a button for navigating back to the product list page. But this is enough for our purposes. Then we activate a route with code and route to the product list page. Note that this is the same code we used to activate a route with code that we saw in the last clip. Lastly, we return false to let the router know to cancel activating the product detail route. Otherwise, we return true and continue on to the product detail page. Now we are ready to hook up this guard to the appropriate route. So we open the file containing our route configuration, which is our app module, and scroll down to the imports array. Let's first reformat the product detail route so it's easier to see. We add the CanActivate property to the route definition for the product detail component and set it to an array. In this array, we specify each guard we want to execute when activating the route. In this case, we only have one. We add product detail guard and let VS Code add the import. Now let's try out our guard. If we view the product list page and select a product, our URL is valid and we navigate to the page. If we instead type in a URL that is not a number, we see our message. The product detail route navigation is canceled and we are redirected to the product list page. It works. Use route guards anytime you want to prevent access to a route, confirm navigation away from a route, or preload data for a route. So let's finish up this module with some checklists. To prevent null and undefined errors in our templates, use the safe navigation operator, denoted with a question mark. The safe navigation operator only navigates to the properties of an object if that object has a value and is not null or undefined. In this example, it won't access the product name unless the product property has a value. We can use the safe navigation operator to safely navigate down a chain of properties as well. Use the ngIf directive to remove an entire set of elements from a template if the value of a property is null or undefined. This is useful when accessing multiple properties or to also hide titles or labels. We can pass any number of parameters to a route. Add the parameter to the route configuration path by specifying a slash, a colon, and the parameter name. Pass the parameter value by adding it to an element of the link parameters array bound to the router link directive. Read the parameter value in the navigated component using the activated route service. Notice here that the parameter name, ID in this example, is exactly the same as in the route definition. To activate a route with code, use the router service and define it as a dependency on the constructor. Create a method that calls the navigate method of the router service instance and pass in the link parameters array. Add a user interface element and use event binding to call the created method. We can use guards to prevent access to a route, confirm navigation away from a route, or to preload data for a route. To create a router guard, we build a guard service. Implement the guard type, in our case, can activate, and create the associated method. We then register the guard service provider with the Angular injector, using the provided in property set to root. Lastly, we add the guard to the desired route. If you are interested in learning more about routing, check out my Angular routing course here on Pluralsight. We now have routing to our product detail component. Yay! However, the product detail component and its associated template are not finished. We only wired up the bare minimum to demonstrate routing. As a homework assignment, try building the remainder of the product detail template. At this point, our app module is looking a little cluttered and hard to manage. Up next, let's spend some more time with Angular modules and look at how to refactor our application into more manageable pieces.